In taking a measurement of some quantity, no matter how good you are or how advanced are your measuring equipment, you cannot assume that your measurement is perfect and that it is the truest value. So meaning that your obtained measurement cannot be perfectly accurate. So when we do a direct measurement, there will always be a doubt that our obtained value is not the true value. So therefore, we need to report. So in recording our measured value, we need to report it together with the uncertainty of the measured value. So to define uncertainty, uncertainty is the range of possible values within which the true value of the measurement can be found. So kapag, for example, kapag nag-measure ka ng length of an object, di ba, alam naman natin na minsan natatapat sa gitna ng linya yung edge ng object, for example. So in this case, you need to estimate. So minsan din, kahit hindi mo napapansin, for example, ang nakikita mo sa ruler, nakatapat siya dun sa tawag dito, sa linya. Pero however, using other tools, for example, other measuring device, nakita mo na nakatapat naman siya, sobra siya ng kaunti. So meron tayong uncertainty doon sa measure na binibigay sa atin nung equipment natin. So in those cases, we need to estimate. So is it closer to the next value or is it closer to the previous value? So this means that when measuring, there is always a doubt in our measurement. So that's why uncertainty is also defined as the doubt that exists about the result of a measurement. So in reporting measurement with its uncertainty, we use the form Q plus or minus delta Q, wherein Q is the obtained measurement and delta Q is the uncertainty of measurement. So this expression indicates that the best estimate of the the best estimate of the true value is found between the obtained value plus or minus the uncertainty of your obtained value. For example, so suppose we measure the length of an object to be 10 centimeters long and determine its uncertainty to be 0.05 centimeters. So to report this measured value, ito yung ano natin, ganito yung pagsulat natin. So we follow this form wherein Q plus or minus delta Q and then the unit. So ito yung 10 centimeters natin plus or minus 0.05 which is our uncertainty. So this measured value means that the true value of the length of the object lies between 9.95 centimeters to 10.05 centimeters. So the true value is unlikely to be less than 9.95 and more than 10.05. So yung true value natin, di ba? Ayan. Especially kung hindi mo alam yung true value kapag nag-measure ka. So yung true value mo can be found within this range only. So given this information, andyan lang yung true value mo. So di ba pwedeng 9.95, pwedeng 9.96, pwedeng 9.97, 10.0, 10.01, 02, 03, 04 hanggang 10.05. So this is the lower boundary or the minimum and this is your upper boundary or the maximum. So uncertainty is a way of expressing our confidence in our measurement. Kasi palagi tayong may doubt kapag nag-measure tayo ng object. So yung uncertainty is our way of expressing the confidence in our measurement. So any measurement that disregards the measure of uncertainty is meaningless. So that is why kapag nag-record tayo, nag-measure tayo, nag-record tayo, we always need to include the uncertainty. Kasi yun yung magbibigay sa atin kung ilang error lang ba ang pwede nating makumit. So the relationship between error and uncertainty is demonstrated by the equation measured value is equal to the quantity of measurement plus or minus uncertainty and then the unit. So katulad nung sa kanina, di ba? Ayan. So measured value is equal to Q plus or minus delta Q and then the unit. So we know already that error is the difference between the actual value and the measured value. So yung uncertainty naman, it is the estimate of the range between your estimate between the range of your measured value and then the true value, wherein it represents yung uncertainty natin represents the reliability of the measurement. So your measured value becomes more reliable and accurate if it is within the range of your uncertainties. So meaning that uncertainty defines how much error lang ang pwede natin na makumit. So for example, if we have a measured value that is equal to 12 plus or minus 1, for example, centimeter siya. So this means that you can make an error of up to the quantity minus 1 or the quantity plus 1. So yung measurement mo, yung error mo, can only, acceptable lang yung measurement mo within the range of 12 minus 1, which is 11, up to 13. So acceptable pa yung error na yon. So kung mag-measure ka, tas ang lumabas is 11 is acceptable because that is within the range of your uncertainty. Kung nag-measure ka ng 12.6, for example, that is acceptable because that is within the range of your uncertainty. However, for example, naging 14 or naging 8 na lang yung measurement mo. So wala na siya. So that is outside the boundaries. So outside these boundaries, the measurement becomes more and more inaccurate and unreliable. So, paano naman natin malalaman kung ilan yung uncertainty ng measurement natin? So, there are two ways of determining the uncertainty of measurement. So, first, we can look for the least count. And second, we can use the range method to look for the uncertainty. So, kanina meron pa tayong isang ginamit, which is to look for the standard deviation. So, dun sa case, di ba, wherein the actual value is unknown, tapos given a set of measurements, then we to look for the uncertainty, we solve for the standard deviation. So you can also look for the standard deviation of a data set. So least count is the smallest value that can be read from any measuring device. So least count is the same as the resolution of your measuring device, wherein resolution is the smallest division or the smallest value that can be measured. So, ano ibig sabihin nito? So, for example, we have here a centimeter ruler. Kung titignan nyo yung ruler nyo, kung meron kayong ruler, meron tayo ditong sa centimeter side, meron tayo itong 0, and then 1. So, yan, that is 1 centimeter, for example. But, if you look at your ruler, meron pa tayo ditong smaller division. So, meron pa tayo dyan na mga ganyan, di ba? So, 1, 2, 3, 4, and then may kita kayong ganito sa pagitan ni 0 and 1. So, meaning that this is not the smallest division. Ito yung smallest division natin. So, ilan ba to? Pag mineasure mo to, ano ba? Ilang value ba to? So, this is equal to 1 millimeter. So, meaning that the resolution of this ruler is 1 millimeter. This is the smallest possible value that can be measured by your ruler. So 1 millimeter. And this is also the least count of your measuring device of this ruler. So as a general rule, uncertainties must be reported with the same number of decimal places as the instrument used. So later on, we'll look at the different examples para mas maintindihan natin itong ano. Kasi yung uncertainty natin, the uncertainty also defines the significant digits in your measurement. So, pinag-aralan natin yung significant digit. So, in real life, so in application, malalaman mo kung ilan lang ba yung included na significant figures doon sa measurement mo by looking at the uncertainty or the least count of your measuring device. So, hanggang saang value ba, hanggang ilang decimal places ba ang pwede mong ilagay. So, yung uncertainty natin is given by plus or minus the least count. So, yan yung pag-express natin ng uncertainty. So, kapag nahanap natin yung least count, just indicate their plus or minus and then the value of the least count. So, in recording your measurement, it must contain the numerical value or the quantity of measurement Q. So, kanina pa tayo nito paulit-ulit. So, and then plus or minus the degree of uncertainty in the measurement. So, don't forget to include the unit of the measurement also. So, yan yung pag-express natin ng uncertainty. So, yung uncertainty natin is given by the least count. So, quantity of measurement plus or minus the least count is the same as quantity of measurement plus or minus the uncertainty. In symbols, ganito natin siya sinusulat. Pero take note also, class, that there is a difference in the uncertainty of a digital measuring device and an analog measuring device. So for the digital measuring device, the uncertainty is simply the measure of the least count. Pero kapag analog device, o kapag analog ang measuring device natin, the uncertainty is 1/2 of the least count. So ibig sabihin, you need to multiply your least count by 1/2 to give, so that is the uncertainty of an analog measuring device. But others also accept the least count as the uncertainty of an analog. Pero para mas accurate yung makukuha yung measurement, kapag analog yung ang measuring device na ginamit ninyo, you need to multiply your least count by 1/2, and that is equal to your uncertainty. So ano ba tong digital and measuring device? So kapag digital, syempre lahat yung nagbibigay na mismo sa inyo ng measure. So hindi mo na kailangan pang mag-refer doon sa mga division ng mga ganyan, sa mga scales. So these are the measuring device that gives you, so these are the measuring device that already shows you the value of the measurement. So no need to estimate, no need to look for the certain value using a scale. So just for example ganito, sa digital balance. That is an example of a digital device. So dito, the least count of digital device, sabi natin kanina, the uncertainty of a digital measuring device is equal to the least count. So if we look at this example, ito, so in this digital balance, the smallest possible value, so yung decimal na binibigay nito is only 1 decimal, so only to the 10th place. So yung ibig sabihin, ang smallest possible na pwede niyang mabilang is 0.1. So 0.1 yung least count niya. Kasi ang binibigay niya lang is hanggang sa isang decimal place. So ibig sabihin, ano yung smallest value? So the lowest possible value of the decimal. That is not 0. So it is 1 in this example. So meron din tayo yung more mas sensitive na digital balance. We have the analytical balance. So yung analytical balance naman natin, it can give up to thousands, hundreds, thousands place. So yan, hanggang yan. So hanggang 4 decimal places yung sa analytical device. So in this case, para sa analytical device, ang least count niya is 0.001. Yan yung least count niya. So no need to multiply it by 1/2 kapag digital yung device na ginagamit ninyo. So therefore, in this example, yung natin, yung banana dito weighs 15.4 kilograms, ay 15.4 grams. So pag ni-report natin siya, we'll have here the measured value, yung quantity, plus or minus 0.1. And then the unit. So meaning the true mass of the banana is found between, so 15.4 minus 0.1 is 15.3 hanggang, so 15.4 plus or minus, ay plus 0.1 is 15.5. So the true mass of the banana is found between 15.3 to 15.5 grams. So on the other hand, so dito meron tayo ditong, ay, tawag dito, analog kitchen scale. So may kita mo naman na analog kapag kailangan mo pa dyan, may kita ka dyan na scale in your measuring device. That is an example of an analog. So when a device is a scale device, that is an analog equipment. So in this example, if we examine the scale, palakihin natin yung scale. So the lowest resolution or the least count is 10 grams. So paano natin nalaman na 10 grams? So dito, di ba, meron tayo ditong 0 to 100. And then yung smallest division niya, ilan ba tong division between 0 and 100? So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, and then pang 10 tong mahaba na linya. So 100 divided by 10 is equal to 10. So therefore, the least count of this kitchen scale is 10 grams. So yung least count niya is equal to 10 grams. So since this is an analog, we need to multiply it by 1/2 in order to determine the uncertainty of this kitchen scale. So the uncertainty of this kitchen scale is plus or minus 5 grams. So therefore, if we report the value, so kung titignan natin, so yung weight or yung mass nung banana dito is about 610. So yan, 610 plus or minus 5. And then the unit, which is grams. Okay, so let us have a concept builder. So this is concept builder number 4 na siguro to. So for the following, so determine the uncertainty of the volume of the liquid and the measured value. Kalimutan ko. So ilagay nyo rin yung measured value. So here, we have here beaker, and this is the scale. And ito din, meron tayo ditong graduation cylinder, wherein ayan yung scale ng graduation cylinder. So by the way pala class, kapag nakita kayo ng ganito na nag-involve na ng meniscus, so always read the volume in the meniscus. So ito yung lower meniscus, yung iba meron din tayong upper meniscus. So always read the volume of your liquid at the lower or the upper meniscus. So for number 1, so you may pause this video and just resume watching after you submitted your answer. So for number 1, so first, ano yung uncertainty ng ano natin ng beaker natin? So yung least count niya, so yung least count niya is 10 ml. So paano natin nahanap si 10 ml? So yung 10 ml niya, so dito di ba makikita niyo dito we have here 20 and then 40 and then meron tayo ditong another line. So itong line na to, sa kalagitnaan ni 40 and then ni 20, this must be 30, di ba? So ibig sabihin, ang pag-increase niya, so from 20, ang increase niya para mapunta siya sa 30 is 10. So therefore, itong interval nito is 10 ml. The measure of this interval or the smallest division is 10 ml. That is our least count. So, yung uncertainty natin, di ba, this is an analog. Since meron tayong nakikita na scale, this measuring device is an analog measuring device. So, yung uncertainty natin, so yan, yung uncertainty natin is equal to the least count times 1/2. So, therefore, the uncertainty here is positive, negative, or plus, and minus 5 ml. So, ano na ngayon yung volume ng liquid natin? So, dito na tayo mag-estimate. So, pag nag-estimate tayo, so, di ba, kailangan natin i-determine yung halfway point. So, just refer to measuring with precision doon sa, ano natin, doon sa, ang tawag doon, sa module natin. So, you need to determine the halfway point. So, meron tayo dito. So, between this line, so, imagine niyo na lang kung nasan yung kalahati nitong linya na to. So, palakihin lang natin. Yan. So, between 40 and then this one, so sabi natin kanina, ang smallest division natin is 10. So, therefore, this must be 50. Itong susunod na linya na to, this is 50 ml. So, we need to determine the halfway point between 40 and 50 ml. And then, determine saan ba napunta yung ano natin, volume. Malapit ba siya sa 50 or malapit ba siya doon sa halfway point? So, nakita naman natin na if this is the halfway point, lampas siya ng kaunti. So, we can estimate it to be from 46, siguro 46, 47, or 48, yan. So, estimate lang yan. So pwede kang mag-estimate na 48 plus or minus 5 ml. Yan yung, ano natin, yan yung, pwede rin naman na 46 or 47 plus or minus 5 ml. Yun yung best estimate natin. Kasi wala naman tayong nakikitang number dyan, di ba? Between 40 and ito, 50, itong guhit na to. So, the best thing that we can do is to just estimate and then add our uncertainty. So, for the graduation cylinder, yung list count natin, yung list count natin is 1 ml. So, if this line here is 20, so 21, 22, 23, 24, and then this is 25. So, therefore, the smallest graduation or the smallest division here is 1 ml. So, this is our list count, 1 ml. And since this is ang tawag dito, this is an analog measuring device, so to get the uncertainty, so U na lang, lagay ko na lang dito, uncertainty is equal to the list count times 1/2. So, therefore, the list count is equal to 0.05 tama, 0.05 ml. Ay, sorry, 0.5 ml. 1 divided by 2. Sorry. Yan. So, 0.5 ml. And then, determine the volume. So, yung volume natin, so kung andito yung ano natin, yung meniscus natin, so ito 21. We know that this is 21 and this is 22. So, determine the halfway point between 21 and 22 and estimate kung saan siya mas malapit. So, this could be 21.5 plus or minus our uncertainty. So, ito yung answer natin. The second method is the range method. So, range method is a way of determining uncertainties in measurements that only applies to averages of repeated measures. So, kung meron kang multiple trials, yan. So, for example, meron kang multiple trials of the same physical quantity. So, you can solve for the uncertainty by looking for the range of your measurement. So, when we have a set of values, using the range method will give us the uncertainty of measurement. So, for example, itong table 1 natin, meron tayong 6 trials and then meron tayong different obtained values. So, to determine the uncertainty of repeated measures, subtract the lowest measurement from the highest measurement. So, dito, you need to identify sino ba dyan yung pinakamalaking value. So, here, nakikita natin 22.3. Siya yung pinakamalaking value. And, the lowest value here is 20.5. So, yung range, yung simplest way on identifying, sabi natin, dun sa module, di ba, precision is using the range. So, wherein we subtract the highest value and the lowest value. So, this method can be used to identify the uncertainty. So, all we need to do, so after subtracting the highest and the lowest value, we need to divide it by 2. Ayan. So, the highest value is 23 ml and then the lowest value is 20.5 ml. So, subtract the lowest from the highest value and then divide it by 2. So divide the difference by 2. So we'll get 0.9 ml. So the uncertainty of this data set is 0. Positive, negative, or plus or minus 0.9 ml. So to report the measurement, to report this measurement, you need to get the average and then yung mean and then plus or minus the uncertainty. So yung ano natin dito, we have here 21.5 plus or minus 0.9 ml, wherein yung lowest boundary natin is 21.5 minus 0.9 is 20.6 ml, and the upper boundary natin is 21.5 plus 0.9 ml, which is 22.4 ml. So there are different types of uncertainty. So we have absolute uncertainty, relative uncertainty. So wherein relative uncertainty can also be expressed as a fraction or as a percentage in percent form. So kapag sinabi nating absolute uncertainty, this is the actual size of the uncertainty. Ayan, this is the actual size of uncertainty. Pero kapag relative uncertainty, it is expressed as a fraction or as a percentage only. So yung size of the uncertainty, in order to know the size of uncertainty, you need to relate the value of your fractional uncertainty or the value of your percentage uncertainty to the quantity of your measurement. So it is important to know this, to know how to get the absolute uncertainty and to know how to get the relative uncertainties of measurement, because hindi laman lahat ng measurement natin ay fundamental measurements, di ba? So some of our quantities are derived quantities. So wherein we need to combine other quantities, yung measurable quantities, together with other measurable quantities. So in those cases, dapat alam natin kung paano i-express yung uncertainty ng derived quantities natin. Or kunin yung quantities, yung uncertainties ng derived quantities. So absolute uncertainty is expressed as a number independent of the original number. So meaning that kahit hindi natin alam, for example, the quantity, so meron tayo dito, quantity plus or minus the uncertainty. So kahit hindi natin alam, kahit hindi given yung quantity natin, yung measurement natin, malalaman natin yung actual size ng uncertainty. Because yung uncertainty natin is simply the recorded uncertainty. So delta Q natin. So katulad nung kanina sa kung paano natin hinanap yung uncertainty using the least count method and the range method. So that is the recorded uncertainty. A number that is independent from our quantity. While fractional uncertainty and percentage uncertainty are values of uncertainties that needed to be related. So, kailangan i-relate mo siya sa quantity natin para malaman natin yung actual size of uncertainty. So yung relative uncertainty natin, it tells us, or it tells us how big of a part of the quantity is our uncertainty, while yung absolute uncertainty tells us the actual size of uncertainty. So to get the fractional uncertainty, it is expressed as the ratio between the original number and expressed as the fraction of the uncertainty rather, and the quantity. So yung uncertainty natin ito, for example, ayan, and then the quantity or the measured value. While the percent uncertainty is simply multiplying the fractional uncertainty by 100. So let's say, for example, meron tayo ditong barbecue stick that measures 20.1 plus or minus 0.05 centimeters long. So just an example. So A, find the absolute uncertainty, B, find the fractional uncertainty, and C, find the percent uncertainty. So suppose that L represents our quantity, and delta L represents the uncertainty of our quantity. So given by this information here. So 20.1 cm is equal to L, and then delta L is equal to plus or minus 0.05 centimeters. So to look for the absolute uncertainty, excuse me, just simply look if given na yung measured value natin, which is in the form of positive IQ plus or minus delta Q. So in this case, we have your L plus or minus delta L. Just look for the value of your uncertainty in your measured value, and that will give you the absolute uncertainty. Kung hindi naman yan given, just recall yung kaninang pinag-usapan natin on how to determine the uncertainty, because your uncertainty is simply the least count or simply the recorded uncertainty. That is your absolute uncertainty. And to express absolute uncertainty, we have here 20.1, our quantity, which is our L, plus or minus our absolute uncertainty, and then the unit. So on the other hand, we have here fractional and percent uncertainty. So yung fractional natin is the ratio between the uncertainty, so uncertainty yan, and the quantity. So yung uncertainty natin nasa taas, nasa numerator, and the quantity is at the denominator. So we want to know how big of a part is our uncertainty of our quantity. So gaano ba kalaki yung uncertainty natin? So 0.05 cm divided by 20 cm, 20.1 cm is equal to 0.002. So to report this, we can write it as 20.1 cm plus or minus 0.002. And hindi natin sinasabay yung, ang tawag dito, yung unit. So take note, andito di ba sa absolute uncertainty natin, kasabay yung unit. So, tawag dito, finactor out natin yung unit. Kasi dito, this is the same as 20.1 cm plus or minus 0.05 cm. Pero dito, yung uncertainty, yung expression of uncertainty dito sa isa, wala tong unit. So dito, sa fractional and then sa percent. Kasi during the fractional, the division of the numbers, maka-cancel out yung unit. So kapag nakita nyo ito na 20, for example, a quantity plus or minus the fractional uncertainty, yung walang unit, number na walang unit, ibig sabihin, this is a fractional uncertainty. Kapag nakita nyo naman na merong percent, ibig sabihin, this is a percent uncertainty. So to know the actual size of your fractional uncertainty, you need to multiply this by your quantity. So in this case, we need to multiply 0.002 by the value of L, which is 20.1, which will give us the value of 0.05. Ayan. So 0.002 times 20.1 cm is equal to 0.05 cm. So on the other hand naman, so yung percent uncertainty natin is just the fractional uncertainty multiplied by 100 in order to express it as a percent. So meaning, yung uncertainty natin is 20% of our quantity. So to express it, we write it as 20.1 cm, which is our quantity, L, plus or minus the percent. So wala dito yung natin, yung ang tawag dito, unit, kasi unitless yung percent uncertainty. Just ilalagay mo lang dyan is percent. So to get the actual size, so you need to multiply 0.2% times the quantity. So which will give us also 0.05 centimeter. So as you can see, kahit na magkakaiba-iba yung expression niya, pare-pareho lang naman yung sinasabi nila. So ito 20.1 cm plus or minus 0.002 is the same as, will give us the same value of uncertainty, which is 0.05 cm. So yung 20.1 cm plus or minus 0.2% will also tell us that the uncertainty, the actual size of uncertainty is 0.05 cm. So the only difference is the way it was expressed. So dito tells us the actual size of the value, while in the relative uncertainties for fractional and percent tells us how big of a part. So gaano ba kalaki yung uncertainty natin in comparison to our quantity. So that's why it is expressed as a fraction or expressed as a percentage of your original value or of your quantity. So, kapag hindi natin alam, for example dito, kung hindi natin alam na ang original value or yung quantity natin is equal to 20.1, so yung 0.002 natin becomes meaningless kasi hindi natin alam, hindi natin magagamit to know the actual size of your uncertainty. Kasi hindi natin alam yung ano natin dito, di ba? Yung original value or the quantity. Kasi to know the actual size, you need to multiply this or you need to relate by multiplying this to the quantity para makuha nyo yung actual size. So the same with the percentage. So the absolute value is the actual measure of uncertainty and shows how large the uncertainty is, while fractional and percent uncertainty measures how big of a part of your quantity is the uncertainty and shows how large the uncertainty is in relation to the quantity or in relation to the true value. So the central problem in error propagation or uncertainty propagation is best conveyed in the question, how do we report the uncertainties of derived quantities? So we know that a derived quantity is dependent on other quantities that can be measured because a derived quantity is a combination of other quantities. So if we combine other quantities, how do we now combine their uncertainties? So for example, if I am to measure, if I am to solve for the force of an object, so yung mass ng object and the acceleration of an object has its own measure of uncertainty. So if I multiplied mass times the acceleration, ano yung magiging uncertainty ng force ko, which is a derived quantity. So calculating with uncertainties describes how to combine measurements with uncertainties. So the combination is expressed as the sum, the difference, product, the quotient, or even the power of other quantities. So there are rules that are needed to be applied involving calculations with uncertainties. So first is the addition rule. So for addition and subtraction, so if data are to be added, or subtracted, we need to add their absolute uncertainties. So kanina, di ba, sabi natin, to express the uncertainty in measurement, we use the form Q plus or minus, plus or minus delta Q or the uncertainty. So itong recorded uncertainty is our absolute uncertainty, which is the actual size of the uncertainty. So sabi dito, if we are to add or to subtract two values or data, we need to add their absolute uncertainty. So for example, if we add A plus B, tapos ang naging result niya is C, so we know that if A is a measured value, so it will automatically have a measure of uncertainty, which is given by delta A. So B will also have its own value of uncertainty, which is given by delta B. So kapag ginumbine natin to, of course, yung sum nila will also have its own measure of uncertainty. Pero paano natin malalaman yung value ng uncertainty ni measure ng sum of these data? So let us express this in this form. So delta A, A plus or minus delta A, and then plus B plus or minus delta B. So this will give us C plus or minus delta C. So to get the value of C, we just simply add the quantity of A plus the quantity B to get the value of quantity C. Pero paano natin kukunin yung value ni uncertainty, which is delta C? So we will base now the value of this to the rule for addition and subtraction. So for addition and subtraction, if we are to add data, the absolute uncertainties is the sum of the uncertainty of your data. So if this is the uncertainty of A and this is the uncertainty of quantity B, the uncertainty of quantity C is given by delta C is equal to delta A plus delta B. So the same with subtraction. So pag subtraction naman, for example, A plus delta A minus B plus or minus delta B will give us C plus or minus delta C. So dito, the same din. So sabi dito, whether it is to be added or to be subtracted, the absolute values are to be added. So kapag nag-subtract tayo ng quantities with their uncertainties, para makuha natin yung uncertainty ng derived quantity, we need to add the uncertainties. So this is for addition and subtraction. For second rule, if data are to be multiplied or divided, we need to add their relative uncertainty. So therefore, we need to look for the relative uncertainties of our data to be multiplied or to be divided. So for example, if C is equal to A times B, so we know that A has its own value of uncertainty and B also has a measure of uncertainty. So we know also that C as a derived quantity also has its value or measure of uncertainty given by delta C. So paano ngayon natin malalaman yung value nitong delta C? That is by getting the sum of their relative uncertainties. And we know that relative uncertainty is the fraction between the uncertainty divided by the quantity. So here, if we want to know the value, if we want to know the value of this uncertainty, what we need to do is to equate delta C, relative uncertainty ng measurement C, delta C over C, is equal to delta A over A plus delta B over B. So this is a relative uncertainty of quantity B, and this is the relative uncertainty of quantity C. So we need to get the sum of the relative uncertainty in order to get the relative uncertainty of C and just derive an equation, a solution to solve for delta C. So later, we'll have an example. So next is for a number raised to a power, fractional or not, multiply the relative uncertainty by the power. So if a number raised to a certain power, for example, raised to n, or a number raised to 1 over n, which is a fraction. So the relative uncertainty, so the uncertainty of the derived quantity is solved by multiplying the relative uncertainty by the power. So for example, ito yung measurement natin, a raised to n plus or minus delta a. So dito, kukunin natin, so para makuha natin yung uncertainty ng derived quantity natin, so ang gagawin natin is, we get the relative uncertainty of our measurement over, tawag dito, we get the uncertainty of our measurement over relative uncertainty, and then multiply it by the power. Ayan. So for the last rule, so for a number to be multiplied by a constant, multiply the number and uncertainty if it is absolute. So kung meron tayong constant number, we need to multiply the constant to the quantity and to the absolute and to the uncertainty if and only if the uncertainty is absolute uncertainty. And if the uncertainty is relative, we only need to multiply the constant by the quantity. So using those rules, kindly answer the following concept builders. So determine the uncertainty of the following. So determine the uncertainty of the following problem. So concept builder number, okay, so number 5 na to. Ata. So yan. So you may pause this video and then resume watching after you submitted your answers in the given Padlet link. So for number 1, yung number 1 natin, sabi dito, the length and width of a rectangle, RL, is equal to 6.5 plus or minus 0.1 meters, and width is 3.4 plus or minus 0.2 meters respectively. So we are asked to find the perimeter and the areas. For letter A, we are asked to find the perimeter. So ang perimeter ng rectangle is simply by adding all the sides of a rectangle. So that is length plus width plus width, or simply 2 times length plus width. Excuse me. So here, so itong value na to, yung uncertainty nito, this is an absolute uncertainty, di ba? Kasi if we distribute this unit to this one, so we'll get 3.4 meters plus or minus 0.2 meters. So since merong unit yung uncertainty natin, this is an absolute uncertainty. The same with the length. So therefore, applying the rule. So dito, we need to add the length and the width. So yung i-apply natin na rule is the addition and subtraction rule for adding uncertainty. So sabi doon, sa addition and subtraction rule, if data are to be added or subtracted, we need to add their absolute uncertainties. So meron tayo ditong value. So yung value ng ano natin, yung measured value natin ng length is 6.5 plus or minus 0.1, and yung value natin ni width is 3.4 plus or minus 0.2. Excuse me. To find the quantity, new quantity, we need to add the quantity of the length and the quantity of the width. So dito, 6.5 plus 3.4 will give us 9.9. And then, since this is an addition between measured values, we need to add their absolute uncertainty. So 0.1 plus 0.2 will give us 0.3. Pero kung titignan natin yung solution natin for the perimeter, so we need to multiply this value to 2. So this is a constant number. So we will now apply another rule. So sabi natin dun sa rule number 4. So dito, sabi natin dito, for a number to be multiplied by a constant, multiply the number or the quantity and the uncertainty if the uncertainty is absolute. So kung titignan natin, if we look at the uncertainty of our given, so yung uncertainty niya, so 0.3 is an absolute uncertainty because we added two absolute uncertainties. So 0.3 is an absolute uncertainty. So we need to multiply the quantity and the absolute uncertainty to the constant. So 9.9 times 2 is 19.8, and then 0.3 times 2 is 0.6. So the perimeter now is 19.8 plus or minus 0.6 meters. So this is the uncertainty for this quantity for the perimeter of the rectangle. For letter B, so finding the area, so sulat ko lang ulit dito yung given. So yung length natin is 6.5 plus or minus 0.1 meters. Yung width natin is 3.4 plus or minus 0.2 meters. And what we want to know is the area and the uncertainty of the area. So you have here the area plus or minus the uncertainty of the area. And we know that the unit of area is squared. So here, so ang unang gagawin natin dito is to solve for the area. So wag muna nating isasabay yung uncertainties. So isolve muna natin si area. So using the given quantity of L and W. So yung quantity ni L is 6.5, si W is 3.4. So 6.5 times 3.4, this will give us 22.1. But since we have here two significant figures, so 22 square meter ang area natin. So since we multiply here the length and the width, so kung titignan natin yung rule for multiplication, sabi dito, if data are to be multiplied, we need to add their relative uncertainties. So kailangang i-add yung relative uncertainties. So therefore, doon sa given natin, ay doon sa problem natin, we need to look for the relative uncertainties of this value. So we need to look for the relative uncertainties. So yung relative uncertainty, alam natin that if we have a quantity, the relative uncertainty of a quantity is given by the uncertainty, the fraction is given by the uncertainty divided by the given quantity. So dito, meron tayo ditong delta A over A. So delta A over A is equal to the sum of the values, the uncertainties, the relative uncertainties of the given values. We have here length, the uncertainty, the relative uncertainty for length is delta L over L, and then plus delta W over W. So no need to add here parentheses. So if we plug in the information, so yung given information, so delta A over A is equal to 0.1 meter. That is the uncertainty, yung uncertainty ng length natin, divided by the quantity of the length, which is 6.5. And then sa width naman natin, 0.2, yung delta W natin, or the uncertainty of W of width is 0.2, and the quantity is 3.4. So if we perform this, so 0.1 divided by 6.5 will give us this value, and 0.2 divided by 3.4 will give us this value. So this is the sum. So this one is the sum of the relative uncertainties of L and W. So kung titignan natin, ang gusto nating malaman is the uncertainty kasi alam na natin yung area. So yung area natin is 22 square meter. Ang gusto nating malaman is the uncertainty of our area. So here, so delta A over A, papalitan natin ngayon yung value ni A by our value of the area, which is 22 square meter. And then we just need to derive a solution for delta A. So by cross multiplying, so 22 square meter times the sum of the relative uncertainties of length and width will give us 1.64 square meter. And based from our definition of uncertainties, dapat ang uncertainties express lang siya into one significant figure. So i-round off natin siya into one significant figure. So we will have an uncertainty of 2 square meter. So now the area 22, ang uncertainty niya is 2 square meter. So as expressed in this form, if we express it in this form, or in this form, so A plus or minus delta A, ito na yung magiging value natin. So 22, ito yung paano natin siya nakuha, plus or minus 2 quantity, yan, squared meter. So, yan na yung area ng rectangle natin. So, next, the mass of a cubical object is 253.1 plus or minus 0.1 grams. So, if one side of the cube measures 5.25 plus or minus 0.05 centimeter, what is its density? So, again, yung given natin, so isulat ko na lang dito, meron tayong mass which is equal to 235.1 plus or minus 0.1 grams. And meron tayo ditong one side of a cube. Yung one side of a cube measures, yung one side of a cube is measured 5.25 plus or minus 0.05 centimeters. And what we want to know is the density. So yung density natin, if we express it in this form together with the uncertainty, so we'll have here the density, the quantity, plus or minus the uncertainty of our density. And the unit for density is grams per cubic centimeter. So first, hanapin muna natin yung value ni density. So ang value ni density is equal to mass divided by the volume. So wala tayong volume pero given yung side natin. So ibig sabihin, to get the volume, we just need to get the cube of this one side of a cube. So this is equal to, the quantity of mass is 235.1 grams over 5.25 centimeter. Yan, so cube. So we'll have here 235.1 grams divided by, so 5.25 cube, so raised to 3 is equal to 144.3125 cubic centimeter. So if we divide this one, so 235.1 divided by the volume, so yung density natin is equal to 1.62. So following the significant digits of our given, 3 significant digits, so 1.62 grams per cubic centimeter. So, isulat na natin tong ano natin dito. Yeah. So, yung density natin is equal to 1.62 grams per cubic centimeter. So, sabi natin, di ba? So, meron tayo ditong dalawang rules na i-apply. So, first, asan na yun? Yung first rule na i-apply natin is yung rule number 3. So for a number raised to a power, fractional or not, multiply the relative uncertainty by the power. Kasi di ba ang given natin is only one side of the cube. So we need to solve for the volume of the cube. So yung volume is S side raised to 3. So here, so yung volume ng cube natin is equal to side raised to 3. So we have here, yung side natin is 5.25 plus or minus 0.05. Diba? 0.05 cm. Ayan yung side natin. So we need to get the cube of this value. So sabi natin, kapag sabi nga natin dito sa rule, for a number raised to a power, fractional or not, multiply the relative uncertainty by the power. So we need to solve for the relative uncertainty of this of the cube of this measurement, and then multiply it by the power. So yung power natin is 3. So we need to solve for the relative uncertainty of this value. So ipasok ko na lang to yung cm and then yung cm. So yan yung gusto natin mangyari. So get the cube. So ano na yung magiging uncertainty ng volume ng cube natin? So first, kunin muna natin yung cube ng quantity. So 5.25 raised to 3 is equal to 144.703125. And then cubic centimeter. So ano yung magiging bago niyang magiging bago niyang uncertainty, yung uncertainty ni volume. So since we have here a power, so kailangan natin kunin yung relative uncertainty, which is delta. So yung ano na lang, S na lang ang gamitin natin, delta S over the side. So this will give us yung relative uncertainty is 0.05 divided by 5.25. 0.05 divided by 5.25 is equal to 9.52 times 10 raised to negative 3. So ito yung ano natin. So meron tong unit, maka-cancel out siya. So ito yung ano natin, ito yung relative uncertainty natin, 9.52 times 10 raised to negative 3. And we need to multiply it by the power. So according to the rule, we need to multiply the relative uncertainty to the power to get the uncertainty of our volume. So yung volume natin dito is volume plus or minus the uncertainty of the volume. Yan. So 9.52 times 10 raised to negative 3 times 3 is equal to, lalagay na natin dito, so plus or minus 0.03. So since yung uncertainty natin is 2 decimal places, dapat yung value natin dito is only expressed into 2 decimal places. So yung volume natin will be, yung volume natin is equal to 144.70 plus or minus 0.03 and then cubic centimeter. So that is our volume. So now we can solve for the uncertainty. We can solve for the uncertainty of the density. So meron na tayo ditong value. So yung value natin for the volume is 144.70 plus or minus. Isulat lang natin dito. So yung volume of our cube is equal to 144.70 plus or minus. So ito, di pa natin alam yung delta D. So plus or minus 0.03 cubic centimeter. Erase natin to. So since we already know the new uncertainty for the volume, kasi di ba ang density is ang density of an object, ang density of an object is equal to the mass divided by the volume. So meron na tayong value ng volume, and meron na tayo kanina, nakuha na natin yung value ni density, di ba? So meron tayong value ni mass. So meron tayong value ni volume and yung uncertainty ni volume. So yung i-apply na natin dito na rule to get the uncertainty of our density is division rule. Kasi dito, to get the density, we divide mass by the volume. So for division, if the data are to be divided, we need to add their relative uncertainty. So again, we need to solve for the relative uncertainty of each of the values. So dito, so delta D, the relative uncertainty of our density is equal to the sum of the relative uncertainty of mass. So relative uncertainty of mass plus the relative uncertainty of our volume. So dito, substitute natin dito, so delta D over D. So yung D, alam natin yung value which is 1.62. So mamaya na ako, so hindi ko muna ilalagay yung unit para magkasya. So yung delta M naman natin, so yung mass of an object, ito yung ano niya, uncertainty niya, which is 0.1 grams. And then yung quantity niya is 235.1 grams. So plus yung relative uncertainty ng volume, which is 0.03 cubic centimeter over 144.70 cubic centimeter. So maka-cancel na to. So we just need to perform the operation 0.1 divided by 235.1 plus 0.03 divided by 144.70. So I will just look for the answer. Excuse me. Okay, so by getting the sum of the relative uncertainties of the mass and the volume, so yung ano natin, yung yung relative uncertainty natin dito will be equal to 6.32 or 33 times 10 raised to negative 4. So to solve for the uncertainty of our density, to solve for the absolute uncertainty of our density, we need to cross multiply 1.62 times the sum of the relative uncertainty. So i-multiply natin siya. So yung absolute uncertainty now ng density natin is equal to 1.02 times 10 raised to negative 3. So kapag ganyan yung value natin, kapag 1 yung uncertainty natin, we need to include other values. Kapag 1 yung kapag 1 yung uncertainty natin. So therefore, the measure of density together with its uncertainty is equal to, dito na lang sa baba, 1.62 plus or minus 1.02 grams per cubic centimeter. So this is now your density, measure of density together with its uncertainty. So just remember, class, that in measurement and in application, there is no such thing as a little mistake. So walang maliit na pagkakamali, because if the error you made is outside the range of accepted values, kahit gaano pa kaliit yung deviation mo from the acceptable values, collectively malaki yung error mo. For example na lang is itong tulay na to. So maliit lang yung deviation niya from the range of acceptable values, but collectively, nagkakaroon ng malaking effect doon sa product of your work. So that's all for this video. So see you in our next discussion. Thank you.